Hello, today we are doing Chapter 6, Section 3. Our essential question is, what are some of the characteristics of the graph of an exponential function? Well, let's first figure out what does an exponential function represent. So on this one, we want to figure out if it's linear or exponential. Well, on that first one, our x's are going up by 1 each time, and our y's are increasing by 2. So the rate of change is constant, it's linear. On B, you're going to find something different. You're multiplying your y's by 2 each time, so it's exponential. And that's how I always remember it. If your y's are being multiplied by the same amount each time, it's exponential. So let's go ahead now and take an exponential function, and we will evaluate for the given value of x. So if you notice, that exponent has the variable. So that is really going to be -2 times 5 raised to the third power. Don't multiply the -2 and the 5 first. Order of operations are important. Evaluate the power first and then multiply, and you get -250. So on the second one, you're going to take 3 times 0.5 to the -2. You could use your calculator to figure that out, and you're going to get 12. All right, take a second, do these 4 on your own. Look back for the other ones as examples if you need to, and then check yourself. Yeah, for 3 and 4, there are actually 3 problems each because you had to do it for -2, 0, and 1/2. All right, here's a core concept. We are looking at growth and decay here. So we've got AB to the x. When A is positive, and when A is negative, it's red, and your B is greater than 1. These are called growth functions. When your B is between 0 and 1, it is a decay. It starts really high and goes down really fast. And if your A is negative, it's a reflection. So let's go ahead and we're going to graph f of x, which remember is a fancy way of saying y. F of x equals 4 times 2 to the x, and we're going to compare the graph to the graph of the parent function, and we're going to describe the domain, your x values, and the range, your y values of the function. So we're going to start by making just a table. Plot those ordered pairs. Draw a smooth curve. So the parent function is going to be just 2 to the x. Whatever's with the exponent is going to be your parent function. On the parent function, your y-intercept is 1. On the new function, your y-intercept is 4. Your domain is all real numbers, and your range is y is greater than 0, because that graph is never going to go below that x-axis. You're never going to have any negative y values. So that's why the range is y is greater than 0. So go ahead, try this one on your own. The parent function on this one would be 1/2 to the x. And if you hear some noise in the background, I apologize. That is Mick, my black lab, batting his food dish around. All right, go ahead and hit pause. Try this on your own. Remember, whenever you're graphing, you can always make a t-table. When you make that table, you're the one who's choosing the values of x. A good rule of thumb is to choose a couple negative values, 0, and a couple positive values. You can always check yourself on Desmos.com as well. And if you notice, that negative sign flips it. It makes it a reflection over the x-axis. So my domain is going to be all real numbers. The range for my black line, my parent function, is y is greater than 0. My range for my red line is going to be y is less than 0, because everything is underneath the x-axis. All my y values are negative. They'll never become positive. See what? Why don't you just try number 5 on your own and see what that looks like? Actually, we're going to skip this example, but I like this one right here. An exponential function g models a relationship in which the dependent variable is multiplied 1.5 for every 1 unit the independent variable x increases. I don't know about you. I read that and that sounds a little bit confusing. But then they tell us g of 0 is 4, so they're giving us an ordered pair. And we are going to go ahead and graph that. We're going to skip the part where we compare it. So there's our first order pair of 0, 4. And then for each one that it increases, it's being multiplied by 1.5. So it goes from 0 to 1, and then your g of x is being multiplied 1.5. From 1 to 2, multiply your g of x, 6 times 1.5, and you get 9. So once you have the table, it's really not as confusing as it sounds. And then you go ahead and you would graph that. And as I said, we're not going to be comparing it to example 3. We were just going to plot it. We're going to skip that one. We're actually going to skip that one as well. So we're going to skip those last 2 examples. I'd rather do those in class, in person, so I can talk about them a little bit more in depth. Take a second, really think about this, and answer these questions on your own. Get ready for 6-4 tomorrow.